Now, there is a concept known as the eccentricity of an ellipse, which really is basically about how round is the ellipse. How close to a circle does it come? So if the value of 2a is only slightly greater than the value of 2c, the ellipse is long and thin. But if the value of 2a is much greater than that of 2c, that means your foci are closer together, then the ellipse is going to be almost circular. See, what happens is as the foci move closer and closer and closer to one another, eventually if they kept moving in that direction, they'd land on top of each other. And that would be the center of your circle. So the closer they are to one another, the greater that, or the more the difference between 2a and 2c, the more circular will your ellipse be. So we can measure this eccentricity of the ellipse by looking at the ratio of C and A. What we know is eccentricity, which we typically label E, is that ratio, C divided by A. C we find by looking at the non-zero coordinate of the focus or foci, and A we know is the non-zero coordinate of the vertices in a wide ellipse. So all we have to do is find the ratio of C to A, and remember, C squared is equal to A squared minus B squared, so therefore C is equal to the square root of A squared minus B squared. Your eccentricity will always be a number between 0 and 1. So if E is close to 1, then C is almost equal to A, and that's when the ellipse is, and the ellipse is elongated in shape. But if E is close to 0, then the ellipse is close to being circular in shape. So it's basically about how stretched out the ellipse really is. So let's demonstrate this. The eccentricity, of that circle or ellipse on the far left is very close to 0. You can see that it's very round, very circular in its shape. As the eccentricities move towards 1, 0.5 to 0.68 to 0.86, what you're noticing is that that ellipse is becoming more elongated or stretched out. So eccentricity values close to 1 are more stretched out. Eccentricity values close to 0 are more circular. So let's say we've got an equation of an ellipse, or we've got an ellipse whose foci are at 0, 8, and 0, -8. Well, notice first that they are on the vertical axis, which makes this a tall ellipse. Therefore, the A square, or the A is going to be, or the vertices are going to be at 0, A, and 0, -A. Well, what we give you here is only the coordinates of the foci, and then we give you the ratio of the eccentricity. That's C over A. So what we can do is set up a proportion. If the eccentricity is 4 over 5, which is C over A, then we can take that 4 over 5 and set it equal to our C over A, and we can find A. So our C is 8. So I'm going to take 4/5 and set it equal to 8 over A. At this point, all I need to do is cross multiply to solve for A. So 4 times A has to equal 5 times 8, which is 40. And then, of course, when I divide by 4, I find that A is equal to 10. So again, because the foci are on the vertical axis, then the vertices will be on the vertical axis as well. So the coordinates of the vertices will be not 10, 0, and -10, 0, because those are on the horizontal axis. The vertices will be at 0, 10, and at 0, -10. Then I can use my C squared equals A squared minus B squared to help me find the value of B. A lot of textbooks call these vertices on the minor axis, they call them covertices. So I can take C squared, which is 8 squared, equals A squared, which now I know A is 10, so that'd be 10 squared minus b squared. So I've got 64 is equal to 100 minus b squared. Well, b squared must be 36 because 100 minus 36 is 64. So now I've got everything I need to write my equation. X squared over b squared plus y squared over a squared is equal to 1. The reason why a squared and b squared are reversed is because this is a tall ellipse. The foci were on the vertical axis, so the a's are on the vertical axis, or vertices. So it's x squared over 36 plus y squared over 100 is equal to 1. And you can always tell when you look at an equation of an ellipse if it's a wide or tall ellipse, because you look at where the bigger denominator lies. If the bigger denominator lies with the y squared, then it's a tall ellipse. If the bigger denominator lies with the x squared, then it's a wide ellipse. So again, I can graph this out on my paper. Just plot those vertices at 0, 8, and 0, negative 8. 0, 10, and 0, negative 10. Plot the foci at 0, 8, and 0, negative 8. And then the co-vertices, as many textbooks call them, are at 3, 0, and negative 3, 0. Those are the edges along the minor axis.